So today we will work on the different aspect section. It's called radical. Radical. Did you guys learn radical?
Yes.
Okay, I can hear you very well. All right, radicals. You guys definitely learned this before, all right? Okay, so like say 5 squared. 5 squared equal what? 25, right? All right, so this is go this way. If we go backward, 25, we call this one what? Square root, right? So this is called
square root symbol is a radical.
So here it became 5, right? Right? Is it correct? Right? Yeah. This one you can notice that. So if I say negative here, equal 25 as well, right? So if you need square root 25, negative part, so it's negative 5. So this is the positive. This is the positive part, right? This is the positive root. Positive root. This is the negative root. Negative root. Uh-oh. Where did this come from? So negative root, right? Okay, so actually square root 25. If you say like this one, you can write into here. All right. So you can see this one, this result actually is 25. All right, let me give some other examples. So this is just a number square. It's became 25. Became 25. And reverse process, we can say find the root process. This find root process, we use some kinds of signal. We call radical signal. So today we're introducing this kinds of called radical process. Try to find just some layers. Earlier we learned these kinds of exponent, square, something like 5 power cubic. You can got 125, and 125 square, not square root, this cubic root, so got 5. All right, so today this kinds of radical means we're introducing something like this, a, and here has n, right here actually have 2 here, we didn't write, when there are 2, we just don't need to write. We didn't write it, right? But here, like if there are 3, we need to write it. So n, right? Can you guys hear me? Okay, so this kind of situation, we can give their server define here. So this one is radicand. We give it their name is radicand. This is the radical signal, all right? Sign, radical sign. So what about that one, this number? What about this one? We call it a radical. We give it just index times radical root, right? Just this one is how much power was off, right? So this is very important. You need to know. This is we call it index. It's called index. All right. So again, all right. Let me clear as partial of them first. All right. Okay. So these kinds of expressions. So we will met these kinds of situation. I know this is numbers. I don't know. Did you learn these kinds of things before in Jessica's class? Did anyone learn this one already before? Or this is totally new to you all? Is it totally new to everyone? I mute most of them. Most people unmute.
No, this isn't new.
So this is new to you all?
No, it's pretty
Is it,
old.
this is new to everyone?
No.
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 So you guys have learned this before, right?
Yeah.
Yeah.
All right, that's very good.
Probably yes.
Very good. So you learned this before. Let's make me easier to teaching this part. All right. So let me give you some quick. Since you learned this before, let's do some small quiz first. Okay. All right. Let's see this one. So you do guys learn this before. Do you know what's the answer of this one?
3/10.
3/10.
3/10. Easy, huh? So this one can be rewrite into like this, right?
Yes.
Is it correct? So this one actually equal, right? Is it equal? No problem. No problem. So it means right now we're introducing some variable. So it means unknown. We suppose A and B is both greater than 0. B greater than 0. So this one can be rewrite into this, right? Is it correct?
Yeah.
Right?
Yeah.
Yeah.
Okay. Okay. All right. So just go back to the one we didn't talk about a little bit earlier. We talked about radical. Say A, and this is A. That's a little different from what we earlier say divide, right? Divide only we write like this. This is divide. This is radicand. Radical. All right. A little bit different here. Divide here didn't do and here most of the time do like this. All right. So the difference between these two, all right. But when you write something, you better write like this. And when you do a divide, you write like this. A little bit, I just keep in mind here. And okay, so this is the one I first want to make. Second one is when we do the square root, a number inside here, we notice any number times is greater and equal than 0, right? So any number, if the square root, this is actually is 2, we didn't write it out, all right? So any number, if they are square root, this number should be greater or equal than 0. Is it correct? If you say square root -1, I know you guys, some of you guys already learned this one can be equal imaginary, but right now not in our discussion range, okay? So this one will be, we didn't consider this is in our current knowledge. We don't necessarily teach. This one, when you go to high school, you will learn this part, but not now. Okay, you go to high school, when you go to college, they will talk about like this one. But right here, we all define this A should be greater or equal than 0, right? So similarly like here, say 16 square root here equal 4. And have some positive and have some negative 4. If you can say at this one 16, they have 2 answers. All right. But if we want to, most of the time, say square root 16, we only need their positive answers. So if you say negative 16, we say this one, all right? So it depends on, this is the in front of here, we call efficiency. All right, so this is number, these kinds of number, you can got a square root is 4. This number you can get positive 4 or negative 4. But what about these kinds of numbers? Only 5, square root 5. Did you guys can notice what's this equal to? Something like square root 2. What's this equal to? Did you guys have any idea?
Radical negative 2 is approximately 1.4 something.
1.414.
Yeah, something like that.
Yep. All right. So here equal what? 1.414.
414.
But another repeat, right? There's something else.
Yeah.
So Leah, earlier what do we learn? Something like say, let's say 2 over 7. 2 over 7 equal what? 1.414, right?
Wait, 2 over 7?
2 over 7. 2 divided 7 equal 1.414.
2 over 7 can't be greater than 1.
Greater than? Oh no, I'm sorry. 0. I'm sorry. You are right. 0.1414. So this
Oh
is
yeah.
a repeat pattern, right?
Be greater than 1.
This is a repeat
Yeah.
repeat pattern, right? This is repeat pattern. This can repeat pattern, can repeat, continue repeat. But this one is not. Here is not repeat pattern. So this is the rational number. Rational kinds of number. This one is irrational. Right?
I thought if you divide something by 7, you have to have 7 different like decimal digits, and
Mhm.
then it like repeats those 7 over and over again. It can't be like 0.14141414.
Yeah. So here have something pattern here. Just like this one has pattern here. You can repeat it, right? So,
Yeah, but it can't be 0.141414.
let me see. I'm sorry. It's not 1.4. I'm sorry. It's maybe different one. Should be something like 22, 0.2. 14 and 6, 2, 8.
7 digits and they repeat over and over again.
Yep, you are right.
Yeah.
Correct. Yep. So not like that. So this one is means these kinds of can, if they have the repeat pattern, they finally can be transferred into fraction, can be transferred into the fraction. But this one number is not a repeat pattern. They are irrational. They are irrational. So this one, we most of the time we don't like express like this way. We just keep as it is. All right. So keep as it is like this. So they never to use some other kinds of decimal to replace them. We just keep writing like this. Something like say square root 3, square root 5, square root 6, right? This square root 7. This kind of is the most simplified radical. Most simplified. Like this inside is the prime number. So they cannot be further simplified. But if they are something like this, what about 8? Square root 8. This one can be, this is a prime, not prime number, right? It's not prime number. And
2
it
radical
can be
2.
Yeah, 2 radical 2.
2 times 2 and square root here. And you can say,
2 radical 2.
Radical 2.
yeah. So this part actually can be separated. You can see this one is 2 squared times here. So this part can be transferred into 2, right? Okay, let me give some more examples. So actually this one you can see, say this is 2 radical 3 over here. Actually writing, this one can be written into 3, the exponent here can be became a fraction, right? Exponent is became a fraction. So this one, it means partial of them can be transferred. Okay, this partial element can be simplified, became this kinds of thing. So you can use some of these kinds of most simplified radical to express the complicated one. So let's do another example. Okay, so yes. Okay, all right, so something like this one, 27. 27 actually can be divided into what? 3 square root 3, right? And
Yeah.
square root. So in this part, something like you can say 9 times 3 square root. They can be separated, right? They can be separated. So it became 3 over the square root 3. Okay, let's do a little bit more. Right now we say 100. These kinds of fraction square root. But now we mentioned this part can be separated as well, right? The 27, the square root, and this part can be square root. So this one can be got what? 3 square root 3, right? Yeah, it's 10. We can simplify to these kinds of wording. So it's making it more easier to understand, more easier to expression. So here is the square root. Here is 2. When most of the time we didn't write it. If I say the index here is 3, so in this one, how can we do that? So this one actually is equal what? Equal, most of the time equal here. Oh, sorry, why it goes to. So here is, no. So this one is equal, let me go this part. So this one actually somewhat, this is 3 equal means this exponent became a fraction like this one. So we teach the exponent earlier. This one we can rewrite 3, right? Is it correct? So the exponent part, like this one, so here is time here. So this exponent actually became after they do together would be became time together, right? So actually it became half. This is one way, but most of the time you guys don't like to do this way because it looks like too complicated. So actually we can do like this way. Say radical 3 here is became here. So the top one became radical 1 and here. So you can see this one, the denominator is 1 and denominator is 2. So still goes 1 over 2. So they are the similar result. Their result is the same, right? So you guys understood these kinds of things before, right? That's be good. That's be great. So I would be talk a little bit quicker. Okay, so since we talked about numbers, we talked about okay, let me go back to repeat here. So we talked about this kinds of thing. This is when this n equals square root, a inside it should be greater than 0. When is just like if there is odd number, I'm sorry, even number. This n is even number. All inside it should be here. If this is odd number, a don't necessarily. A can be anything, any numbers, any real number, right? Right now, like say, you can say right now square root. I'm sorry, it's not square root. It's the power 3 root square. The index is 3. Like this one, they still have answers. So this one, like you can be rewrite into like this. right? So you can got the answer is 1/2. So this inside don't necessarily should be greater than 0. But when they are even numbers, when index n is even numbers, the inside should be greater than 0. That's the two things to mention, right? So when got this situation, this is most important thing you need to keep in mind when we do a lot of solutions and equations. We need to make sure when they are square root, or maybe the n is 4 or 6 or 8, the inside behind here radical, this number should be greater than 0. That's the definition. Okay, so we got this one. So if we say x square root, here 2, I don't necessarily write out. So here it became absolute value, right? Is it correct? Any number is square, its square root became the absolute value. Something like 25. Oh, sorry, I cannot use this number. So -5, something like -5, their square root is became 5, right? It's actually is -5 absolute. It still became 5, right? Is it? Anyone can understand this one?
Yeah.
Yep.
All right. Very good. Very good. So let me go next one. So all right. So can you guys do this one? Use practice this one. So this one equal what?
Z to the third.
Z.
Z cube. But here, most of the time you need to add here. If their J is less than 0, I mean J is a negative number, their cubic is not correct, right? So you need to add this one. Make sure there is a positive number finally come out. Okay. All right. So let's do another one. Sorry. What about this one? So here 27 is take it out, it became 3, right? So y square. So this one definitely is good. You don't necessarily the absolute value, right? Okay, let's see this one. What's wrong here? So here is got 4x 8, right? Okay, so let's see another one. Right? It's easy. Okay, let's see next one. This one. So 125, the square, not square root, this cubic root is the -5. So A became 4, right? And B 5.
5.
Yep, 5. So that's would be easy one. All right. So since we do this one, this is simplified process. Just make it simplified. We can take some of them out, make it easier. So what about, earlier we talked about A times B, and this one we can, if A and B both greater than 0, they can do this kinds of separation, right? Use something like this. We make sure that A and B should be greater than 0. greater than 0. It's a real number and greater than 0. So it can be simplified and something like, say, let me go another. Let me see another one. Say 54. We talked about this one some earlier. Actually, we'll say 27. This one can be 9 times 6, right? So it can be equal to 9, 6. So equal 3 square root 6, right? Something like say square 200. This one you can 100 times 2. You can get me. You can got it here, right? What about this one? This one is cannot be further factor, right? So because it's 5 times 7, and both are prime, and you cannot get a kind something what kinds of number square. You cannot find it. There's still you cannot be further simplified. Still itself. It cannot be further simplified, right? Okay, so something like say this one. So be careful. Some of the writings. I don't know what's going on with my screen.
Would there be a code?
Huh? So
The code.
oh yes, homework code. Wait a minute, I will be sending out a little bit later right now.
Okay.
I will after finish this one. So here it'll be, so something like this one, you can be further simplified, right? So actually 3 times this 8 we know can be factoring, can be taken the fourth
Radical
2, right? The 2 take it out. So the 2 after here, take it out, it became this one. So 3 times 2 it became 6, right? Like this kind of simplified expression. That would be easy part. But what about this one? So this one is so simply why we talk about radical only itself. So what about this one? We say 50 plus. Okay, let me give to another. Let me put to another drawing page. Let me clear all this first. So we talk right now. We only talking about one term. So it's simplified by itself. So if what about if they have two terms like this one? So we can do each of them separately, right? Something like this one, you can become 25 times 2. 25 take it out, it became this, right? And what about this one? This one is 4 times 2, right? This is 25 times 2. And this 4 can be taken out, became 2 and square root 2, right? So since this is the same, this is the long number, we cannot be I know this is considered a number. You can consider this is an irrational number, right? So this is became coefficient of them. You can consider this is an unknown number. This is unknown number. So this one can be combined into 7 square root 2. Right? Is it good? Okay, let's see another example, quick example. See this one. This one is 4 times 3. This one can be say 25 times 3, right? So it's still 7. This 4 take it out, it became 2 square root 3, right? And minus here became 5 square root 3, right? So here became 14. This part can time together. And 5 minus 3. So you can see this is unknown things. So this looks like collect terms. And this one could be changed into this. So it means this one can be further simplified until like this. Did you see this interesting? Right, that's very interesting one. Okay, let's see another example here. It's almost time over, right? But let's do it just quick. 25 27. Can you guys do this one and then review and to see what's coming out? Yes, it's 16 here. So this one is 5, right? This one can be changed into 3 square root 3. And this one is 9/2, right? 9 take it out, became 3. And times 2 becomes 6 square root 2. And what about this one? Here is -4. All right, so you can got what? So this term can be combined. You can 1 minus 3 square root 3. So this one cannot be further simplified. This is the final word, final answers. Okay, so that's interesting. This is very basic one about radical. We didn't talk too much about them, but I assign a fork maybe beyond this what we're talking today. You try your best to do the homework. All right. I don't require you guys all can do all of them very correctly because of some of them may be already out of. I didn't teach yet. All right, so let's today's code. Please write down first. Let me see my report. And today we'll be talking here radical introduction and operations. But the operations I only talked about simplify, addition, and minus. I didn't talk about times and divide. Maybe you guys already learned before, but try your best, can do it. So this is the code, 970539. Can you guys please copy down? And if you're done, you can prepare for leaving.
Thank you.
Thank you. Bye.
All right. Wait a minute, before you guys leave, I need to 13 people here, right now. I mean, I know some people already leaving.
Can we leave now?
Wait a minute. Some people already leaving, but it's fine. I need to know who is coming today. I think 2 people is already leaving. Right now I have 13 people.
Can we leave now?
Yeah, if you already copy this code and can leave. All right. Talk.
Bye. Thank you.
Thank you. Thank you.
Alright.
you.
Thank
Alright.
you.
See you next week. And I have 2 more people coming up, but it's leaving. All right. I will log it out and log in again. All right. Abby and Jane, I think it's Luke, right? I'll just log in 5 minutes. All right. I log it out and we'll come back. Right?
Dang it.
Yeah. I'll log it out and log in at one more time because I need to put something ending here. Thank you. All right. I just right back in 5 minutes.